Hi guys, so I have a bunch of people who are still confused about how to enter a circuit into the simulator and get data out of it. So let me just go through an example. Here is the sample for lab 1. I'm not going to do the whole circuit because that would leave anything for you guys to figure out. So I'm going to do a part of it though, just to kind of get you started. So there's a 10-volt supply, a 1000 ohm resistor in series with that, and then a 3.3 and 5.6 thousand ohm resistor combination in parallel, but that combination is in series with the 1K. Then these two guys out here are also in parallel with the 3.3 and 5.6, but I'm going to let you put those ones on. Let's see how this works. So I'm going to pop over to the simulator. I'll make a new laboratory document, and it'll take a second here to get its head screwed on. Okay, there we have the prototyping board. I'm going to open the component tray and go find a power supply. So there's one right here. I'll pop it into my layout, and then we need some resistors. So I'm only going to need 3 resistors because I'm only doing those 3. 1, 2, 3. Actually, I'm going to move this one over 1. This one over 1. Okay. Now, first thing I want to do is to connect the power supply. So let's take the positive terminal of the power supply and connect it to this power supply rail on the prototyping board, and the negative terminal and connect it to the other power supply rail on the prototyping board. Notice this guy is connected all the way across, so if I connect anything to this row, it's connected to the negative terminal of the power supply, and anything connected to this row is going to go to the positive terminal. I can also, while I'm at it, connect up the power supply rail on the other side of the prototyping board so that these guys down here are also equivalent to connecting to the plus and minus terminal on the power supply. So let's go back to the layout. Let's put in the wires needed to connect the 1K resistor. I want to go from the positive terminal of the power supply to one end of the 1K and the other end of the 1K to the top high potential side of the 3.3K. So first let's connect the positive power supply to one end of the 1K. And the other end of the 1K I'm going to connect to the high potential side of the 3.3K. Oh, I forgot to mention, let's go ahead and set the resistances on these two. 3.3K. Notice the resistor codes change, the color codes change automatically when you type in the value. So in this lab, you don't actually have to look up color codes because the simulator does it for you. In lab 2, you'll have a schematic you're trying to match, and you'll need to look in the box and find the resistor that matches a certain value. In this lab, the color codes get put in for you. So the 3.3K, of course, is connected back to the negative terminal of the power supply. So let's go ahead and hook that up. And then the other end of the 3.3K connects to the high potential side of the 5.6K, so let's hook that one. So I just added this wire right here. And finally the 5.6K, the other end, connects to the negative terminal of the power supply, so I just added this wire here. So I've got all 3 resistors hooked up to the power supply, and we're going to consider the potential at the bottom to be ground. So now I can start the simulator. Actually, before I start the simulator, let's add some voltmeters. So I'm going to throw in a multimeter. Got one of those guys right here. Let's put in 2. So I want to measure the voltage across the 1K. So I'll put one terminal of the multimeter on one side of the 1K and the other on the other side, and same with the 5.6K. This is exactly how you do it in the lab when you connect a multimeter to a circuit. You take the positive terminal and connect it to the high potential, the negative terminal connect to the low potential, and you make your measurement that way. So let's go ahead and fire that thing up. Now, instructions say we want to run at 10 volts, so I'll zoom in here, dial this guy up to 10 volts. There we go. And you can see that the voltage across the 1K is 3.25 volts. The voltage across the 5.6K is 6.75 volts. And that's how it works. Now, does this make sense? Yeah, it does, because 3.25 plus 6.75 is 10. So you can see that if you go back to the schematic, the voltage drop across this one, plus the voltage drop across this guy, the 3.25, plus the voltage drop across this guy, the 6.75, it all adds up to 0. 10 minus 3.25 minus 6.75 is 0. So that's how you connect the circuit up in 1, 2, 3D circuits. Let's go ahead and do the same thing in Spice. So I'll first put in a power supply. There's that guy. Then I'm going to go ahead and put in some resistors. I'll put the 1K. And then down here I'll put the 3.3K and the 5.6K. Then I'll put in some wire. And I'll put in the ground. Let's see, I want to that guy, and then let's go ahead and set some values here. 10 volts, 1K, 3.3K, 5.6K. Good. And then we should just be able to run. Oh, I forgot to put in my set point command. Here we go. Operating point. Pop that down here. And we'll go ahead and view the error log. And there you see it. 6.75 and 10 are the two voltages. That leaves 3.25 for the drop across the 1K. And there you have it. So let me know if you have any questions.